Next presenter is Shiva. That's me. And then, all right, so I'm gonna share my screen. If Dong can time it and let me know if I'm running out of time, it would be great. Okay, let me share my screen just a second. Okay, so good evening, everyone. Before I start my presentation, I want to make sure everyone can see my screen and hear me okay.
Yes, now that clear.
All right. Okay, so today I'm going to present a few software testing concepts that I have learned throughout my journey of this course. So for today's agenda, I have the importance of software testing, Beezer's 5 testing levels, detecting a fault in code with test cases and repairing it. I would also like to provide a brief introduction to input space partitioning and input domain modeling. Then I will discuss graph coverage with this application in FSM. After that, I will provide some insights on how to plan, implement, and manage test processes. Finally, I will provide 5 ways of selecting effective test cases for regression testing. So as our textbook is divided into 3 different sections, I have tried to include 3 topics from each section in this presentation. I have used my findings from discussion questions, PAs, and CLAs for these topics. So yeah, let's start with why software testing is important. You know, as we all know, a few years ago, there were 2 Boeing 737 MAX crashes in Ethiopia and Indonesia, resulting in total deaths of 346 people. So the reason for these crashes was the malfunctioning of MSCS system, which stands for Maneuvering Characteristic Augmentation System. So the way the system is designed to work is there are 2 angle of attack sensors that provide input to MSCS system regarding the current position of the plane with regards to the wind. So based on these inputs, an MSCS system determines the nose rise or dive direction. In this case, the software didn't alert the pilot and resulting in taking over the pilot's control when the failure happened. This pushed the nose of the plane down and then the fatal crash happened. So when there are thousands of components in a system and there will be millions of things that could go wrong. So in this case, it was a sensor and MSCS system. Overall, a rigorous integration testing that is required to prevent these software failures from happening again. So obviously, such a catastrophic failure doesn't occur frequently, but this case study provides a solid reason for why software testing is very important. So my next topic is Beezer's software testing levels. It ranges from 0 to 4 based on the goals of testing. So the level 0 states that testing and debugging are basically the same and there is no any difference between them. And level 1 mentions the purpose of testing is to find the correctness of the software. Whereas level 2 says that the testing is to show the software doesn't work. And level 3 highlights that the purpose of testing is not to provide anything specific, but to reduce the risk caused by the software failure. And then level 4 emphasizes that testing is a mental discipline that helps all professionals, software professionals, improve the overall quality of the software. So these examples, the piece of codes on the left and right are from my PA1 assignment. So the purpose of this code is to find the last index of 0 from the array passed as a parameter to last 0 method. So as you can see, the fault in this code can be detected as we pass along few test cases. So when we pass this array 0, 1, 0 as an input to this method, this iteration is going from the beginning of the array. And that's where when there's 0 in the beginning of the array, it will return that index. So which is not what we want. We want to return the index of the last 0. So So the quick fix of this fault in this code can be the traversing the array from reverse direction. So it's starting from the end and going up to and including 0 in decremental order. So yes. And then my next topic is input domain partitioning as well as input space partitioning. So input domain is the possible values that the input parameters can have, which can be gigantic in some applications. So this input domain can then be partitioned into regions that are assumed to contain equally useful values from a testing purpose. So as shown in figure 4, the input domain D is partitioned into 3 blocks, B1, B2, and B3 based on the common characteristics. Input domain modeling is the process where we model these input parameters based on the semantic of the program. And there are 3 steps that can be followed for input domain modeling. The very first step of input domain model is to understand the source code and derive testable methods and functions. And then the second one is to identify all parameters affecting those testable functions and methods. And finally, we can apply some input space partitioning. A simple but yet effective domain can be modeled based on that. So, as Beezer said in his popular book, Software Testing Technique, testing is simple, and all tester needs to do is to find a graph and cover it. So one of the most common graphs for testing source code is the control flow graph. For this graph, as we can see in figure 5, the nodes represent the statement blocks. So these are the nodes. And then the edges represent the conditions. So node 1 is a decision node because there are more than one out edges, whereas node 4 is a junction node because it has more than one in edges. One of the example for graph coverage is the application would be Finite state machine, which is a graphical representation where nodes represent states and edges represent the transition between different states. So it can be very useful in testing the state behavior of the software. So this is an example of microwave oven FSM, the Finite state machine that I drew in my CLA1 assignment. As we can see in figure 6, there are 6 states, and then software can be tested with various inputs to observe its behavior based on the finite state machine graph. So these states I have identified as idle state, cooking interrupted, cooking finished, as well as lamp on and off. So when we talk about managing the test processes, this is a goal-oriented testing methodology where objectives of testing are identified at each stage of development and test activities are performed to meet the objective. So for example, when we look at this software development lifecycle, which starts from requirements, design, implementation, validation, and maintenance. So just to give an example, if we are managing the test for this state of development, we can now set our objective being efficient integration testing. That will be our objective for this stage. So in order to achieve that objective, maybe we'll have to do some rigorous integration testings and design the integration test cases as needed. So, and it can be applied for all different states. So identifying the objectives and performing the test activities. The test planning process and implementation offers a different perspective. We can have a different perspective on requirements when they are viewed from will it work. And it can eliminate, it can also provide any drawbacks or any missing concepts or missing requirements in our requirement and specification phase. Otherwise, they could be easily misunderstood or could be missed. So to explore this testing perspective, let's look at the requirements broadly classified into 6 different types. So when we look at functional requirements, we can ask some questions like what an application must do. And when we look at environmental requirements, we can ask questions like where will it run? Will it run in the mobile app environment or different operating systems? And definitely there are other requirements that we can look into, like standards, usability, if this the software would be usable for the users, as well as the security, where we can make sure this system is safe enough and it can prevent the threats from external attackers. So this is selecting test cases for regression testing. So as we all know, regression testing is rerunning or revalidating already ran test to make sure there is no extra bugs or anything else in the software. So, as we all know, regression testing is very important, but when it comes to perform those kind of testings, the resources and limited times might be on our way. So since rerunning tests, can be expensive and time consuming, we need to be able to select effective test cases that can represent all these the past tests that we have done. So in order to select very effective test cases for regression testing, we can look at 5 different selections. So one is we can select the test cases with frequent defects. And then the second one would be we can select the test cases that verify the core product features. So for example, of the email software, if the core main feature is to make sure the safe delivery and receiving of the email, then we have to make sure even if there's anything else changed in the software, we have to make sure those core products features are addressed. And then definitely the test cases for most recent changes. And then the other one would be all integration test cases, because since integration test cases will take care of all different components of the software, even if there's a small change in some component, if these test cases have been passed, it's a good sign the changes has not done any damage in the overall software systems. And definitely the successful and failed test cases from the past testing that we ran. Okay, so just to come to a conclusion, through my presentation, I have demonstrated a case study of Boeing 737 MAX crashes to illustrate how important software testing is. And after that, I also ran through 5 Bezier software testing labels, and I presented a faulty code and also provided a solution to that code by running through different test cases as an example. And after that, I went through different input space partitioning as well as the input domain modeling. And to touch in the graph coverage, I presented the control flow graph for the if-else structure. And after that, I presented an example, an application of graph coverage using a finite state machine of microwave oven. And then I described how to manage different test processes in 5 development stages of software development lifecycle. And then I provided some insights on test planning and implementation. And at the end, I provided 5 ways of selecting effective test cases for regression testing. These are the references that I used. And yeah, thank you. Do you have any questions?
I really love your presentation, especially for the case study, the Boeing 737, and I think everybody would like to, know the importance of the software testing after that, and would love to learn more about this. And other than that, the example about the last zero for the fault repairing and the microwave for the finite state machine are also very intuitive and easy to follow. And obviously it's a well-organized presentation and it's also very interesting. Thank you.
Thank you, C. Thank you so much.
Yeah, and the Boeing example really get my attention, and it tells me how important the test is. And also, I would want to say like it's very ambitious. How to say? It's very brave to present so many topics in such a short time, and you made it very well. And also, I like the slides because it could tell like how many efforts you put on this presentation. Thank you.
Thank you, Zikai. Thank you so much.